Hi, very good morning. Today we are going to explore the potential of zone architecture and then the respective challenge that we have in that particular architecture. Okay, now. So among them, we are going to discuss nearly 4 points. Right. Among these 4, the first one is power distribution. Right. In zone architecture, we are using something called decentralized with smart protection method. Previously, we had a centralized power distribution method. We used to have a centralized power distribution unit. From there, every ECU will get their power. Right. But in zonal, it is slightly different. Right. Here, the power is distributed to each zone. The zone controller or the power distribution zone module that we have in the respective zone distribute the power to the module associated with that. Okay, that's how the power is distributed in case of zonal architecture. Okay, so here they have compared both of them, like domain architecture as well as tomorrow's zone architecture. Right now, in this diagram, they have detailed, like we have a central power distribution unit. From there, we get the power to every ECUs those were connected in that particular system. Right? It is a centralized power distribution which does the job. Right? Here we have for each and every ECU we use fuses which protects the system when there is a overcurrent or something like that. Right now, the traditional fuse and the relays are used as switches, right? Traditional relays, right? So the characteristics of this particular centralized system is the centralized wiring, longer harness, because we have a centralized distribution. From there, each issue should get the power. The weight wise, they are higher because we have more cables and then more ECUs. Limited visibility, like clarity, because they are very much complex, the visibility is very less. Then it is very hard to scale. When you want to scale them, scale the network, it is very challenging to do so. Right. In tomorrow zone architecture, the power distribution is done in a decentralized way. Right. The power from the battery is distributed to each zone. From zone, it is distributed to the respective sensors, actuators, and ECUs connected in that particular zone. Right. So here they are using something called a smart fuse. What is smart fuse? The smart fuses uses sleep transistor. Sleep transistor is no, I think it's not a sleep transistor. No, in smart fuses, they use a transistor-based fuses, transistor circuitry, which act as a fuse to shut down the power of the ECU module when there is a overcurrent. Right, that is the advantage with this smart fuses. Again, it is resettable. See, if there is a failure in the fuse, in the traditional sense, we have to remove that fuse from the network, remove the fuse from the device, and then have to fix a new one. But here it is sometimes they use some sort of switches to reset it. Sometimes they use software to reset that fuse. That much of flexibility that we have in the smart switches. In zone architecture, they use these transistor-based fuses to control the overcurrent. I understood, right? The overcurrent or the impact that is created by the overcurrent or short circuit. Right? It is decentralized power distribution, as we discussed it before. Shorter and light wiring, because the powers are distributed from the zone to sensors and actuator, the wirings will be less. Right? Then built-in protection and diagnostics. These smart fuses contains the built-in protection, so they won't failure, they won't burn, they won't create any hazards. they also have a diagnostics, whether they are good or not, that we can diagnose. Understood. And the reliability of these smart fuses or power distribution is higher than the traditional one. You can scale it. When you like to scale it, you can do so, right? And it is something called as module power gating. What is module power gating? They use something called as a sleep switch in this particular zone controllers. They shut off the power when a particular sensor or actuator is not used. Control, or which shut off the power when the component is not used. When it is used, the power is supplied. So from this, they are controlling the static current leakage. So when the components are not used, we need not spend the current, right? When the particular sensors or actuator is not used, we no need to spend the current. So that's why we have a concept of sleep in automotive, right? When we turn off the ignition, they will shut down the clock signals applied to different peripherals of the ECU or peripherals of the controller, and they will put the controller in idleness so that it will consume the power or current in the order of micro or milliamps, right? Because we have to connect the battery to the vehicle forever, 24/7. It doesn't mean that we won't turn off the battery when we turn off the ignition. So though the ignition is turned off, that battery is still connected with the network, which will create a static leakage current. That means every module will consume a small amount of current, though it is turned off. So if it is connected with the battery, to control it, to reduce it, they use something called as MOSFET based sleep transistor that helps to shut off the power when a sensor or actuator is not used. So which in turn saves the battery life. Right now, that is called as module power gating. Understood. So let us summarize the challenge now that we had before and how the zone architecture address it. Right. It is the challenge that we have in the domain architecture is transitioning power distribution architecture and ensuring reliability, protection coordination, and EMC in the decentralized environment. These are the challenge that we have. That means when you have the centralized power distribution, you face these things. What are those? Transitioning power distribution architecture and ensuring reliability. Reliability, you will have a issue, and then the protection coordination and EMC in decentralized environment. How the zonal architecture address that? Smart fuses in the zonal module provide a intelligent selective protection and visibility while reducing wiring complexity and enabling energy optimization. These are the advantages right now. So we have to remember two things with respect to zonal architecture power distribution. One is the smart fuse, another one is the module power gating. Right now, these are the key things to remember, which is used in the zone architecture. Okay, now then sensors and actuator. What is the current state of sensors and actuators? Those are connected with the ECU, mostly passive devices, right? So they will have for each ECU will have a sensor and actuators, limited local intelligence. That means they cannot. There is no exchange of information between these sensors or actuators. Higher ECU processing load. The ECU, as these actuators are connected directly with the ECU, right? ECU of the system. So the processing load of the ECU will be more, and more wiring domain, right? So we have more wiring in this one, right? These are the characteristics of current sensors used in domain architecture. Sensors and actuators used in sensors and actuators used in domain architecture. So what are the advantages or what are the characteristics of these zone architecture, the sensors and actuators, right? In case of zone architecture, your sensors and actuators are connected with zone, front zone module or a zone module, a zone controller right now. These sensors are smart sensors. They have their basic microcontroller within them, which does all the initial processing. Let's say if there is an image, when you have a camera sensor, they can get the image from the camera and can digitize them. After digitizing it, they can encode them in an appropriate manner that is required by the front zone module. In the previous case, the cameras are directly connected with the ECU controller, so it has to do those things. But here, the sensor itself comes along with a sensor itself provide the ready-made binary data about the image with the required format to the system, to zone controller. It is very easy for them to work with, right? That's why they are calling these sensors as smart sensors and actuators. Similar way, we have the actuator. Most of the basic actions, those were required, are done by these. The controller, those are associated with that sensor and actuator itself. Right now, that is the advantage. So here we are saying like this, the characteristics of these zone architecture sensors and actuators are they use a smart sensor and smart actuators, right? They use an embedded processing because the sensors and actuators comes along with an controller, local diagnostics and calibration. So most of the basic operations are done there itself, in sensor or actuator itself. Less wiring and high accuracy and reliability, because these are smart, so they can produce a reliable result, right? So let us sum up the challenges that we have in the sensors and actuators of domain architecture, how it is addressed in the zone architecture, right? Evolving sensors and actuator to smart devices and managing interoperability, diagnostics, security, and calibration at scale. So these are the challenges that we have. That means when we have a new type of sensors, those cannot be interfaced with our traditional domain architectures. We cannot make it optimized. Otherwise, we cannot connect them directly with the centralized ECU. See, the challenges here is evolving sensors and actuators to smart devices and managing interoperability, diagnostics, security, calibration. In this sense, we have the traditional sensors and actuator lacks in these areas. When it comes to zone architecture, they are intelligent sensor, right? Intelligence move to zone edge, enabling the smart devices with the standard interfaces, improved diagnostics, and simplified integration. These are the advantage that we get when we go for smart sensor and actuator, right, in zone architecture, which is somehow a decentralized network.